Hi everyone, this is Bryan from Acala. So today I'm going to presenting you some work we have been working through in past few weeks. This Chopsticks. So let me share my screen. Nice. So yeah, so it's just some links first. Actually, little bit background context on why we're building this and exactly what's the problem that Chopsticks is trying to solve. Um, sorry that I only spent like tiny bit time making a slide so it doesn't look good. But as engineers, I think most of you guys understand, will understand. Yeah, so as a Acala builder, during building the Acala operational maintenance upgrades, I believe a lot of Parachain things share same pain points. Like for example, every runtime upgrades require a lot of testing. I still remember the times that when we did like the first run upgrades in Kurura, we just hope it works. It ended up being working, that's great, but just you never be really confident that it actually works. But so it's to make things easier, so we obviously maintain multiple test nets, and then obviously we test a lot of things in the test nets. For example, for every runtime upgrade, we try upgrade the exact same version runtime on the test net first, and make sure the test net is still working perfectly fine before we submit the version to the mainnet. But simply just add a lot of overhead that we're maintaining Acala, maintaining Kurura, so we need to have one test net for Acala, one test net for Kurura. We also have another Mandala test net for which is a different runtime, which cannot be used for this kind of testing purpose. So this now is a three test net. We also have, for example, Rococo test nets, and previously also had Western test net. So there's a lot of test net on the hand. And yeah, I believe like a lot of other Parachain things also maintaining a lot of test net. They will understand this. And that is still not enough. That we don't do enough testing for a lot of on-chain operational, and that end up being a costly lesson. So we decide we need to do test every on-chain actions before submitting to on-chain. But the reason we didn't do that not because we are lazy. It just a lot of actions just doesn't make sense to try now test net first. Like for example, on Acala we have various incentive program that are scheduled to end at, for example, after 2 weeks. So that, we're using scheduler features to schedule like change the incentive promise after 2 weeks at a particular block. For those kind of things, it just simply infeasible to test them on testnet because like the block number obviously on testnet will be different than the mainnet block number. So the transaction will not be exactly the same. We're still going to make mistakes if we say enter wrong block number. Then like we kind of not really want to wait 2 weeks for that to end on testnet to observe the behavior. So just a lot of things just requires eyeballing to make sure it actually works. And we are also close participants of the Polkadot and Kusama governance. And I also observed a lot of mistakes. There are a lot of governance actions that if Raul is here, he will know. There are a lot of governance actions failed all the time on both Polkadot and Kusama, but there were, I know there's at least a few cases that they failed multiple times repeatedly. Yeah, again, it's not like people are lazy to test them. It just test them is hard. And before I create Acala, and I have been working on but on Ethereum, that writing solidities. So I have some feelings about the toolings on the Ethereum side. Then they do have some good toolings. Like for example, like if you're using when I'm working with Ethereum, that's like a few years ago. But at that time, like when you're doing truffle, building smart contracts, one of the first thing it does is like create a local mainnet fork and try to deploy the contracts on the mainnet fork before deploying the contracts to the actual mainnet. And then researchers just doing all different crazy experiments on on a local mainnet, trying to find if there's a bug, trying to reproduce errors, trying to see if there's new front-running strategies, etc. They all happens on a mainnet fork, and those experiments are impossible without the ability to fork mainnet do it. And then there's a lot of quite advanced toolings to analyze transitions and traces it, to create a nice detailed outlines of exactly what happened during execution of the transitions. They were super useful for example, reverse engineering the transitions. So those are great on Ethereum. This kind of is one of the things, at least we want to achieve similar developer experience on those things. So quite a while ago, actually, let me see, how long, this like 2.5 years ago, I implemented system dry run transitions with the goal to, dry run the transition. So we would know if it's going to fail or not. If it's going to fail, then we must not bothering submitting the transition. And it turned out this implementation is not really useful because I can't figure out how to do this at that time. Because it will tell you if transition is going to fail. But a transition, there are two kind of transition failure. One is rejected by the transition pool because, for example, you don't have any tokens to pay transition fee. Another case is transition is included in the block, but failed to execute it for whatever reason. For example, if you transfer money more than the balance you have. In this case, the dry run will tell you the transition success. So it's not useful, and write issues about like this is not useful. We need to make a return event so this can be useful. And even if we do implement these features to make a dry run useful, it still doesn't solve pretty much all the problem I just described previously. Like it cannot be used test front upgrades, it cannot be test governance action because they all are scheduled with scheduler and executed in the future block. So you can dry run the submission of the proposal, but you cannot really dry run the proposal itself. So I was seeking to build a solution. So I at the state I just write issues like we really need ability for mainnet. And there are a bunch of discussions, and then let's start doing some research. There are some suggestions. So basically, there's a Substrate SAM node to for end-to-end testing as well as small dot. So I tried and researched then, create my draft design. Then I just basically implement this, and we have Chopsticks. So the goal is for the mainnet. It's basically a testing client for the mainnet and allow developer to just submitting transition on the forknet. And just that is useful, but not exactly enough because there are a lot of things we need to modify the forknets to make things useful. For example, you want to test case that might spend a lot of tokens, and you probably don't want to import private keys of your account with a lot of tokens and just to write some tests. So we need the ability to override the storage and to allow test account to have a lot of money. And then it will be even better if we can just submit transaction on behalf of other users. So we can just do a lot more testing just without a lot more setups. It will be more realistic compared to mainnet. So yeah, I've implemented exactly that. So a quick demo time. So this is the Chopsticks repo. So yeah, so currently it can take parameters in command line, or it can take in the configuration file. And so in this case, the configuration for Acala is like using this endpoint, Acala endpoints, going to mock the signature host. It's going to fork at this particular block. All the data are cached on this SQLite database to make things faster. and then going to import override storage. So Acala, we do have the sudo palace, and the accounts on the mainnet is set to the treasury account, so no one have the private key. But for testing purpose, it's just super useful to have the sudo. And then I'm going to give the alias bunch of tokens and bunch of tokens. So I can run this, and then yep. So yes, so I can use Polkadot.js apps connect to my testnet, and the last 4 hours many days ago. Yeah, then I can just the basic implement instant sealing, so I can submit the transition. You can see alias have bunch tokens, and you should just create me a new block. And yep, a bit slow, but you can see that it's a new block being created. And then because I have sudo, wait, I should have sudo. Yep, I have sudo. And I can just say do a runtime upgrade. So that's actually the latest Acala version. I can just submit sudo. And then I can verify this new runtime actually works. It doesn't immediately, you can see the validation function stored. That means the new version is available, but it's not going to be applied unless there is a Parachain go ahead signal sent from relation. So we implement in such a way, it will detect this is a pending version, and then we'll send a mock go ahead signals, upgrade signals on next block. So you can see now the validation function is applied. I need to do a refresh. Some subscription method RPC is not implemented, so I do a refresh. You can see the runtime version have been upgraded, and then I will be able to just query the storage. I don't have a lot of pre-image here, but I can just query the storage and just verify there are a bunch of migrations on this version. So I can query the storage to verify all the migration actually works. And then I probably should just create a bunch of fake proposals before the upgrade. And then after upgrade, I can just verify then it works. So this allows nice, easy ways to verify runtime upgrades as well. I can pretty much connect to this with Acala front-end depths. And then I can just do a swaps and a bunch of other things on this testnet and verify everything works. So yeah, this is pretty nice and simple for Acala. So I'm going to show this, run this for Kusama as well. Because there was recent release of the governance tool, and people just trying things there. I also received the pull request issues on Chopsticks that people want to test the fellowship and how it works on Kusama. So yeah, it's a perfect use case for Chopsticks as well. So the configuration for Kusama is a bit more complicated. I need to mock the timestamp, otherwise it will trigger a session change, which makes things a bit more complicated. But I basically override the console, the technical committees, so I can fast track runtime upgrades or whatever to indirectly gain sudo privilege. And I also mapping storage for fellowship is complicated, but I was basically making alias to be the solo member with rank 7. So I can again do bunch testing. But of course, if you want, you can give more fellowship members to do web testing a lot. This not only override storage, but also delete this other storage first, and then insert storage. So you delete other fellowship members. And then to refresh, I can see this is Kusama and fellowship. then you can see Alice is the solo member, and that is a wireless core. Then I can test both. And yeah, so basically you now can do a bunch of testing with this. Another thing that, for example, features I also implement is there are a lot of Photoshop things that requires a lot of block time passing. So I implement the RPC, that new block that is, well, creating new blocks, and I can ask to create 10 blocks. And then it would just, well, doing exactly that, creating 10 blocks. And then I can verify things are working. That is one pending improvement to be made is that creating block is quite slow. So I cannot just creating 500 blocks to fast forward to sometimes in the future. But it works. Yeah, I believe that this is confirms that it's scheduled dispatch. So yeah, you can see this works. Yeah, so this essentially what Chopsticks today. You can fork Acala, fork Aurora, fork Polkadot, fork Scamma. You can probably fork a bunch of other parachains. Well, you need to just try it yourself. Then you will know. Let me know if it doesn't work. Then yeah, you can just submitting transitions and testing runtime upgrades, testing new runtimes, and testing things. Let me go back to my slide. Yeah, there are a bunch of commands if you want to run yourself. So it's published to npm, so you can using npx run or yarn drx. I recommend using a config file, so you don't need to pass like 5 parameters. And a bit more about the implementation detail. How exactly is this implemented? So this is all possible thanks to Small as the was an executor. I tried. You can probably see on my issues. Yeah, I tried implement this with Substrate, and it just not going to work. One of the main reasons is that Substrate directly kind of depending on a native runtime. It's just impossible to get built without pulling a native runtime. Now it can definitely run without native runtime, but it's just bad. I don't want to pollute this project with Acala code base because then I can never be sure if it's going only work for Acala, if it's going to work for other projects. So I definitely want to avoid pulling native runtime. Then Substrate just not a solution. And Small I tried implement everything and as using Small and they end up being just very hard. Partially because Small is still new each project, and I end up I also well, I'm not that familiar with it, so it's very time consuming. So as a quick compromise, I decided to only using the WhatsApp executor part, which is very nice. Just with I don't know, probably half hours, and I have a nice POC able to make runtime API calls, and it's great. And the rest I'll just implement it with Node.js. So I have a Node.js server serving the WebSocket request, serving the Substrate RPC request. So as long as like all these RPC requests get the good enough values, then from the SDK side, you won't be able to tell if there's a real or fake client. So they should be good enough. So to run the WhatsApp executor, obviously you need a storage. So this will feature the storage lazily from the remote node. So only feature storage when it's needed. So it doesn't have to download all the storage from remote share, which could be huge for some of the parachains. With the storage, and yeah, it feeds to the WhatsApp executor to call runtime APIs, and then there are a bunch of APIs. If you're familiar with Substrate, you would know there's like block building APIs, create new blocks, apply extrinsics, finalize block, etc. Basically, just calling those APIs, like how Polkadot host does. And after result, you're getting a bunch of storage diffs, and then having those diffs saved to the local blockchain implementation. And also using the SQLite to cache the remote code to make it faster. Yeah, I guess I can give some quick code overview. So basically, this executor is the Rust code. That is not a lot of code. The proof handling code is a lot, but otherwise it's relatively small. And the core part is it's the task. So the core is this core, which calls a runtime core. Basically, just using the libraries from a small dot, so I don't need to do all the hard work. And then this very nice interface from a small dot allow me to do certain things. So for example, if it wants me to provide some storage, then in this case, this will call into the WebSocket interface, WebSocket server hosted on the Node.js server to get the storage. And then in here, storage, and in here, then this will just try to get the storage. And this blockchain implementation can either return the storage from in memory or from the SQLite DB, or fetch from the remote node. And then yes, get prefix key and get next key, verify signature, and then there's the path there where I can mock the signature to bypass the verification or not. Yeah, that's essentially the core interface. So I can just using this executor to execute the Wasm runtime. So this is compiled as Wasm. So you can run in the Node.js server. And in future, when we package this as a library, then this can run inside browser and mobile wallets or browser extensions. Yeah, so just show you this. There's a block building code. There are a bunch of hacky things to deal with oral consents or baked consents and trying to fake the digest and getting fake headers working. But basically, yeah, I'm calling like the Wasm APIs to initialize the block, doing some hacky things, override storage to bypass a bunch of checks, apply extrinsics for inheritance, which is set timestamp, and as well as set validation data for Parachain. Apply extrinsics for user submit transitions, and finalize block. And all the storage for each previous task, I just push to a storage layer of the local blockchain data structure, and create a block and finalize it, update the block head, and we have a new block. So all these are relatively easy, just using the right Wasm cores and implement the right blockchain data structures. And yeah, so I managed to get this working, get the first POC working in 2 weeks, and then get it mostly working with like in Kusama and Polkadot and other Parachains, most feature working now. Back to the slide. Future work. So if you want to help contribute, see, I do have some issues layout indicating what is going to happen next. But basically, yeah, there are a bunch of performance improvements I want to do. Currently, creating a blocks takes multiple seconds, which makes it not really suitable. Say, if a governance voting takes 2 weeks to decide, we want to see what happens after 2 weeks. We really want to be able to fast forward 2 weeks worth of blocks under a few minutes, if possible, to reduce the waiting time. So there are some improvements to be made. Like, for example, we might just want to be hacky bypassing calling runtime APIs at all, for example. Yeah, then one of the next cool thing is be able to not just test one network, because like as Polkadot, we are internet blockchains, we're all interconnected with each other. So just testing one chain is useful, but a lot of functionality depending on other blockchains. So it's super critical to be able to test, do the multi-network testing. So the idea is, well, with the configuration file, then yeah, we can just spin up bunch of the instance of the Chopsticks and to simulate that relay chain, multiple parachains at the same time, and then just similar to how Polkadot delivering, relaying XAM message between relay chain and parachains, we just implement the same thing. Monitor storage, injecting the new storage to the new block in the other parachain. So it should be very straightforward. Just need takes time to implement. And with that, then we'll be able to do XAM testing. And so we'll be more comfortable with all the upgrades, not just your own chain, but other people's chain, to make sure the upgrades doesn't break your current code that depending on XAM code on there. And there are a bunch of developer experience improvements. Obviously, one of the core idea is use this to do tests. Like right now, it's super useful to do a manual test as well as some end-to-end tests, but there are definitely more improvements can be made. Like for example, create like as well as from Ethereum Ganesh too. They have the ability to make snapshot and restore to a particular snapshot for testing. Like this is super useful to avoid lengthy, time-consuming setup phase. Like if you want to, for example, test a liquidation on Acala, we need to set up the stablecoin CDP engine parameters. We need to set up swap pools. We need to inject liquidities, bunch of configuration, multiple Oracle price, borrow some money, multiple Oracle price, trigger liquidation. There is a lot of setup required. So with snapshot, then we can just do a setup once, make a snapshot. And then in the future tests, we just restore to a good known state and continue from there. Yeah, library mode. I want to. I make sure the wasm part, sorry, the Rust part is comparable to wasm. With the hope we can ship this to front-end extension mobile app, so that we can use this to truly dry run transitions, and then we will be able to run a transition, knowing exactly the storage difference from this transition. And then because we are able to decode the storage key and values to human readable formats, then we can display to users, hey, your performance transition, you expect to reduce your balance by 5, increase your dot balance by 10. The storage will be modified. Then you exactly know the impact of a transition before submitting it. You don't need to try to figure out what exactly is this redeem something means. You don't need to worry about it because you will see, my balance increased, my balance changed. And yeah, and then dry run XAM transitions that right now is, it's super common to do cross-chain transfers between parachains. But one problem is sometimes the transition success on the source chain, but failed on destination chain because, for example, the weight requirement have been changed. You submit transition with not high enough weight, for example. If you only simulate on your chain, the transition is going to success. It's going to dispatch the XAM message, but the result is still fail, but you don't know. So it's also super critical to be able to not dry run transition on the source chain, but as well as the destination chain, so that we can know this end-to-end experience is end up being a successful outcome or not. And then that would just make the user experience much better, and less likely people lost funds due to like those configuration errors or capability issues between multiple projects. Because it's like with more and more projects, it's just getting harder to make sure all the runtimes are perfectly aligned. Yeah, I also always want to have a tool to analyze the blocks and storage change by a transition. I asked those issues like almost 3 years ago. So the idea is we can focusing on storage change instead of events. But events are super useful. But a lot of time they are not enough. Like for example, I want to not every transition balance changing events emitting balance change events. Yeah, at least at some stage, if that's the case, that wallets I keep complaining. I want to monitor user balance change, but it just changed without event. That happens. So if we can just simply monitor the actual raw storage, we're not going to have this issue. And also, there are some special there was some special case that events simply get discarded during migration, I believe. There should be fixed, but still, that just means the event isn't that reliable. So I really want to focusing on the storage. And there's a lot of times we just forget to emit events. Yeah, I believe I still have a few issues on Polkadot about this. Another use case I really want to implement, I probably want to focus this next after Chopsticks, is the wasn't view functions. Again, this idea is coming from since beginning of Substrate. Like everyone with sort of the experience, first thing they come to Substrate, how do I implement view function so I can query the user balance? So there I can, for example, implement the rebasing tokens. The balance changes all the time. Change every single block. You need to do some calculations to calculate the balance. How do I write a view function so I don't need to implement the logics twice, one in the blockchain, one in the front end? That was simply not possible. Still not possible today. And we can make custom RPC calls to kind of achieving the same functionality. But if you have implement custom RPC, you know how much work required to do that. It just annoying. And it breaks. Like for example, the transition payment RPCs was kind of broken due to the wait V2 upgrades, causing the old clients not handling the runtime interface with wasn't correctly. I literally just received a bug report today about Acala, one of Acala nodes. So that isn't good enough. The wasn't view function. I proposed this quite a long time ago, but that was because it was not feasible to do this. So I'm at that time, but with Chopsticks, this is actually feasible. So that we can execute a bunch of code, and in the wasn't executor, and the storage will be supplied however I like. Then we can totally compile a special wasn't function. It will run the wasn't function, which will query the storage as the normal Substrate runtime does. And I will supply the storage, of course. I will record the storage being called. And then I can create a dependency graph. That's wasn't function depending on those five storage. And then I can subscribe to those five storage. And if they change, I can just record the wasn't function and deliver updates to the front end. This value have been changed. So let's create a super efficient and nice way of like this view functions to also be run everywhere. I think this should be able to prevent like much better user experience. And we still don't have standards on token APIs, but this could replace that, because like you want to know the balance, just call this wasn't function with this parameter, you will know the balance. Then you don't need to care about how the balance is handled at all. Yep. So that concludes my presentation today. So I guess I would, make the rest Q&A time. So stop sharing.
There's a bunch of questions in the chat, but it would be great if you guys could ask the questions, because it would be much better for the recording. So Joe, I will start with you. Joe? Okay, there we go.
I'm here.
Could you ask your question out loud, please?
Yeah, sure. 1 minute. I'm in like a big room, so I'm just going away where other people don't hear me. Yeah, so like most of your demonstration was about setting up a new node to maybe test like a runtime upgrade on a parachain itself. So like this is quite useful for parachain developers, but then there's like another layer of developers, like application developers, who want to maybe develop an application using a bunch of different parachains and XCM and stuff, and they don't want to run a node and all of this like very CPU intensive stuff on their computer. They just want like something that emulates all of the runtimes of all these chains so that they can develop on top of it. So I know like we discussed it in the forum thread, and you said that Chopsticks could do that. So I was wondering if you could talk a bit more about that side of it.
Yeah, so as I just show you today, that I can run a Acala node and a Kusama node. Well, not really a node, but I can emulate a Kusama node and Acala node locally. And that is, well, it's not syncing blocks. It's not downloading blocks from internet. It's not validating blocks. It does nothing if you don't submit transitions. So it's not using resources at all. The only time you use resources is when it's building blocks or it's querying storage. Then while it's querying storage, you need to download the storage. When it's building blocks, it's calling the wasm function to call a block, but it's just calling a wasm function. It's not compute intensive at all. So it's super lightweight. You probably already know small dot or Substrate connect is able to run the light clients for a bunch of Parachain nodes at the same time using minimum usage, and this is mostly powered by small dot. And the Node.js side doesn't do a lot of work by itself. And so I see no reason why you cannot run like 10 instances of this, which each instance is a Parachain. And then later on, as I stated in the roadmap, I would like to implement the XCM and parts to connect all the instances together. Then we can just test XCMs. And so ideally, I would like to one button fork the whole Polkadot networks, including all the Polkadot Parachains locally.
Yeah, exactly.
And,
like,
yeah,
there's be like 3 user groups for this. Like one is the parachains that you obviously covered quite in depth, and then there's like wallets and infrastructure developers. Like you could kind of imagine, like you just said, like you clone the entire Polkadot network, like all the parachain runtimes and runtime RPC endpoints and everything. And then like if you are developing a wallet, you could just have like a unit test that will just go through and test like every RPC call that it needs to make across every parachain, and it can validate that like its wallet works across the entire network. And then you could do the same for like applications. Like they might not care so much about the RPC endpoints like wallets or infrastructure provider will, but they want to know like what's the functional API of all of these parachains and how can I use that to develop my application. So they're mostly focused on like emulating that and like what kind of runtime calls can we make for storage and transactions. So there's like 3 user groups of this, and it's like almost too powerful. Like, yeah, I think like it kind of needs to be split into 3 products or like 1 product, but to make sure that they have like clear user stories for each one.
Yep. Like right now, it's just matter of exposing the functionality to call into the runtime call directly. Like is, for example, they show is using the runtime API calls to create new blocks, and then we can just expose them, and then the other developers can just call in this runtime API call directly with whatever custom data they want to provide, and yeah, that will be useful for a lot of use cases.
Dennis, I think you were next.
Yep. So the question was about some specific level of testing. So reproducing the events you would never want on your relay chain, on your parachain, like something very specific to some kind of attack, some kind of testing of the consensus algorithm, and whatnot. So is it possible to craft the test-specific chain for like one test case, one chain? It's very short and concise, so our tests are very fast.
Yeah, exactly. We spent actually quite a bit of time supporting this kind of scenario. And basically, we allow the ability to spin up a new chain based on Genesis JSON file. So instead of forking a mainnet, you can using whatever tools you like to generate a Genesis JSON file with whatever storage you would like to have. And it will just create a network based on the Genesis JSON. And then it should be fairly straightforward, implement the ability to export the current block state as a Genesis JSON, and you can just have it saved and next time load up for new testing.
And Natalie, I think you're next. And then of course, oh no, wait, sorry. Sander had a comment. Maybe Sander, then Natalie.
Yeah, no, it doesn't. Like I was just saying that the thing with being able to see the storage changes for like when you do a dry run, like that would be super awesome to have integrated into Polkadot.js, so you can see what will happen there. Like that would be dream come true. So that's really interesting.
I personally would love to see Wallace implement those features. And so when I sign the transaction, it would just emulate and tell me the result before I sign in the transaction.
Cool.
All right, Natalie, over to you.
Yeah, I wanted to ask, so if there's like a summary or kind of if there are like types or clusters of use cases where you would say, here I would always recommend using Chopstick for, or where like the canary network doesn't help or fail. So I understood like different assets. That's kind of hard because you don't have the same IDs, then probably like, yeah, every time like governance upgrades also. But are there kind of clusters also where you would recommend using Chopsticks for? And out of interest, how often do you have problems? And what are kind of examples of like failed governance kind of proposals?
Yeah.
Fixed?
Yeah, we definitely use it for every runtime upgrades. And I'm always going to test the new runtime with us to verify all the migration, other things actually works. And then for governance, yeah, this can be useful. Right now, there are still some limitations on governance that, for example, what already be useful is that I can create the pre-image of a governance call and submit within to-do. And then I will know the immediate impact of this call and make sure that is exactly what I want. But it doesn't work that well for the more complicated setup. For example, schedule something to happen in the future. Then I would like to, again, as already described, I have the ability to fast forward very quickly, probably by skipping producing blocks at all to a future block, and then starts producing blocks to verify that this kind of will result the right behavior. And then I'm also thinking about that because people don't always, people can maybe already test the governance proposal before the submitting on chain, but I don't know if they test it or not. And so I would like to verify if it works before casting a vote. And so I would imagine I would probably want to create some script that featuring ongoing proposal, and then just simulate it. There's enough on-chain data, we know exactly the pre-image when it's going to be in ed, and then we can just simulate there's a bunch of whales voting a lot of A, and then time like whatever voting periods pass by just as nature occurs, and then it go in ed, and then tell me the exact outcome. Potentially would be I will imagine some JSON-like thing with exactly all the storage keys and values, so I know, hey, the treasury, for example, treasury amount reduced by 500, this account increased by 500 if that's expected. Then I will know exactly the impact of the proposal, and then they'll definitely help me to make sure I'm comfortable with the vote I'm going to cast. And a lot of governance error is that because the origin configuration is just complicated. We have experienced multiple errors recently on Kusama because the open governance change that makes certain governance action require different origin than initially proposed. The result is that it's just not going to execute the proposal. And with this, we will just know, oops, this is not going to execute at all. Then there's no bother to do this proposal. We probably need to resubmit. Those kind of easier mistakes can be caught much earlier on.
Thanks. So it would also work on OpenGov. And
yep.
Yeah.
As I demoed, you can set up the fellowship and other things. It should work. But of course, I only done limited testing. So welcome to play a bit more and submit issues if I find anything isn't working.
Awesome. Is there any other questions for Bryan? If not, then Bryan, thank you so much for taking the time, and please feel free to send over any content that you want the team to, the developers to look over. And thank you again for taking the time. I know it's late where you are, and thanks to all the other developers in the ecosystem that joined. And we'd love to do more.
Thanks, everyone.